In this video, I am going to demonstrate how to solve a rather complicated trigonometric equation. So this equation has many of the ideas that we've looked at in class all put into one problem. So let's get started. First thing I want to notice is that I have a mixture of different trigonometric functions. I have cosecants and cosine. And anytime I see I have cosecants, secants, cotangents, I like to see if there's any way that I can change those to sines and cosines. If we can change our functions to sines and cosines, it makes things much easier. And so the first thing we're going to realize is that we know that the sine of some angle t is equal to 1 over the cosecant of t. Those are reciprocals. This is one of the many reciprocal identities. And so I'm going to use that idea here. If sine of t is 1 over cosecant t, then sine squared t can be 1 over cosecant squared t. So what I can do then is I can replace 1 over cosecant squared with sine squared. And that would give me 15 sine squared t plus cosine of negative t equals 9. So that's one of the important reciprocal identities. The next identity I want to use is one of the negative angle identities. And that's going to get rid of this negative angle, because here we have a negative angle, but over here we have a positive angle. Just like changing all of our trig functions into sines and cosines, it's also easier if we can change all of our angles into positive angles. And so we know that the cosine of a negative angle is equal to the cosine of the positive angle. And so this is identity number 2 that we're going to use here. And so I'm going to replace cosine of negative t with the cosine of positive t, which I won't put in parentheses just to simplify it. Okay. So make sure that you are familiar with all of the various negative angle identities. The next thing I want to do is, and this is an algebra procedure or an algebra maneuver, not necessarily trigonometric, but we want to have this set equal to 0 because we can see over here we have a sine squared, so we have some form of a quadratic. So I'm going to take and bring the 9 over to the left-hand side and make it a negative 9. So we're going to always want to set our equations equal to 0. The next thing I want to notice is that I still have 2 different functions, 2 different trigonometric functions, sine and cosine. At least I've gotten rid of the cosecants. Now, I ask myself, can I factor anything here? Is this factorable? And as it turns out, it is not factorable. So the next thing I want to look at are some more identities. And so the next identity to take a look at is sine squared t plus cosine squared t equals 1, which we can rewrite as sine squared t is equal to 1 minus cosine squared t. This is one of the Pythagorean identities, and that is the third identity that we're going to be using in solving this problem. So I'm simply going to take out sine squared and put in 1 minus cosine squared t. And then we just have a little bit of algebra to do on this. Multiplying this through by 15, we have 15 times 1 minus 15 cosine squared t plus cosine t minus 9 equals 0. Now the 15 and the 9 can be combined, and so I have negative 15 cosine squared t plus cosine t. 15 minus 9 is going to be plus 6 equals 0. Now the next algebra move that I want to make in algebra technique is to multiply both sides by 1. Multiply by -1. What that's going to do is it's going to change all my signs. So I get a positive 15 cosine squared minus cosine minus 6 equals 0. And now I've got it set up where it is actually factorable. But first, let's just do our u substitution. Let's let u be equal to the cosine of t, and that'll be something that is a little easier to work with. Minus u minus 6 equals 0. So we have a trinomial, and we want to factor this into two binomials. Now, there are a number of ways, as I've stated in class, to do this. You can use the AC method, or you can use the trial and error method, which is what I basically did to factor this. And it factors into 3u minus 2 times 5u plus 3. And you can verify by foiling this. 3u times 5u is 15u squared. Negative 2 times 3 is negative 6. And then the inside term is the sum of the products of the inside and the outside. So we have negative 2 times 5 is a negative 10u. 3u times 3 is positive 9. Negative 10 and positive 9 is a negative 1u. So again, this is just factoring and checking it by foiling. The next thing that we want to do is set each factor equal to 0 and solve for u. So u is equal to 2/3 and u is equal to negative 3/5. Then we want to say that then we want to replace u with cosine. So we then have cosine of t is equal to 2/3, and the cosine of t is equal to negative 3/5. We're getting there. So then using our inverse trig functions, t is going to be equal to the arc cosine of 2/3. And this is actually going to give us two angles, so I'm going to call this T1. And then we have t over here is going to be the arc cosine of a negative 3/5. So let's take a look at our angles. First, over here, this is going to give us an angle in the first quadrant because cosine is positive in these two quadrants right here. And so this is the angle that has a positive cosine. So it's something in the first or the fourth quadrant. And we're looking for angles between 0 and 2 pi. So the first angle is simply going to be the arc cosine of 2/3. So this is going to be T1. The second angle is going to be all the way around here. And it's going to have a reference angle of T1. So that angle is actually going to be, so T2 is actually going to be 2 pi minus whatever T1 is. Then let's call this angle T3. So we have cosines that are negative in these two this quadrant. So T3 is going to be this angle right here. That's T3. And then T4 is going to be this reference angle down here. So it's going to be this angle all the way around to here. And so that could be found by doing 2 pi minus T3. All right, so the only thing that I haven't done in this is go into Desmos and find out what T1 and T3 are. Okay, so again, T1, you find out in Desmos. T3, you can use by going to Desmos and just type in arc cosine of a negative 3/5. Then to find T2 and T4, you can also use Desmos by simply going in and doing 2 pi minus T1 and 2 pi minus T3. So let's actually go and do that. So let's open up Desmos. All right, so Desmos, we have T1, I'm going to write T1 is equal to the arc cosine in parentheses of 2/3. That gives me T1. T2 then, we said T sub 2 is equal to 2 pi minus T sub 1. And that gives me my T2. T sub 3 was equal to the arc cosine of a negative 3/5. And then T sub 4 is equal to 2 pi minus T3. Okay, and that gives us our 4 angles. All right, hope this video was some help.